Okay, so skipping that first page is just giving you formulas. Uh-oh. I think. Why are you telling me no signal? There. Okay, let's get that out of the way. We're going to go right to the next page, I hope. Oh, shoot. Forgot my glasses again. Sorry. No, I'm chained. Lauren's on it for me, though. Uh-oh, you know what? They're not there. You won't find them. We'll record them. I forgot because we stood outside today, so. I have not yet copied it. Alright, that's fine. Alright. Let's try again here. What you have a picture of there is a velocity function. It's the velocity of a body moving in a little trig function there. I'm going to do a trig function for you because they seem to be more difficult for folks, so we might as well do one of those together. And we want to find the net change in the body's position from time 0 to time 3/2. Another word for net change is displacement. So basically you want to find the difference in distance from where you ended and where you started. We don't care where you travel in between. We just want to know the difference in distance from when you ended to when you started. There we go. To do this, it's actually fairly easy process. We're going to integrate the velocity curve from 0 to 3/2. If we look at it picture-wise over here, we're finding this area. So hopefully already as you're looking at this, you're thinking, I see a negative answer in our future, which would mean you can think of it in terms of right and left, right? The object moved left more than it moved right, or you can think of it forward and backward. Okay? So, if we want to go ahead and integrate this, do we need a u? We do, don't we? Let me come over here. We need a u. What is our u going to be? Pi t, yep, pi t. So du is pi dt. And we have still a 5 hanging out there as well, don't we? Right here? Okay, multiply by 5. 5 du is 5 pi dt. So, let me write this on here once, just without the u's. There we go. Okay, I know now as soon as I put those u's in, I'm going to want to change the limits of integration. So if I plug a 0 in over here, I'm still 0. If I plug a 3/2 in, I have 3 pi over 2. Okay there? Alrighty. So I'm going to have cos u. And in place of this 5 pi dt, I'm going to put 5 du. I'll put the 5 out front. Du. Good. Let's integrate. Integral of cos? just plain old sine, right? 5's just going to come along. 5 sine u from 0 to 3/2. Here we go, fundamental theorem of calculus. Oh, sorry, 3 pi, thank you. Okay. 5 sine 3 pi over 2 minus 5 sine 0. Sine at 3 pi over 2, that's down at 270, -1. And at 0, 0. So this is -5, and I think we're in meters. So -5 meters then was your displacement. You end up to the left of where you began. That's our net change in position. Any questions on how to find displacement? Oh, let's write displacement here. That's another word for displacement. Okay. This one, exact same situation, except that I'm not trying to find displacement. This time I'm trying to find the total distance traveled. So if this object went back and forth, I'm going to count everything now. Okay, I'm going to count everything. For displacement, this is similar, but not exactly the same, a little bit more difficult. I'm going to use the absolute value of velocity. So let me show you what that means in terms of our picture up here again. Move this back up for a second. What that means is I want to count all this area just like I did before, but I'm going to count it all as positive now. So basically I'm going to flip this part up. So it's all above the x-axis. I want to count all the distance that we traveled. Does that make sense? Okay. So you know what this means. We got to get those absolute value signs off because we can't do a thing with them on there. Now let me just put my velocity function in here first. Same exact one I had before. Cos pi t dt. There we go. So I know I'm going to have to break this integral up. I'm going to have to determine when this is negative and when it's positive. Well, how am I going to do that? Yeah. If I don't, though, have a picture, right, I'm going to have, I'll come up here and do it. I'm going to take my velocity, or whatever equation I'm working with, and set it equal to 0. Okay? In this case, I can divide both sides by 5 pi. 5 pi is a positive number. It is safe for me to get rid of it. I can do that. Okay. I'm going to solve for pi t, my angle. And I want to list here the places where cos is 0. So cos would be 0 at pi over 2, 90, okay, and 3 pi over